Hello and welcome to this presentation about Puma. My name is Ricardo Cabrera Nyst, and I work as a senior architect at the Esri Research and Development Center in Zurich. So what is Puma? Puma is a plugin that enables running CityEngine rules into the Rhino and Grasshopper environment. As you probably know, architects and urban designers are normally not very familiar with coding. And that's one of the reasons why Grasshopper's visual programming became so popular among them. Now, with Puma, we can make use of CityEngine rules within the Rhino application. Now, how does it work? Let's jump straight into Rhino and see what's all about. Alright, so here we are inside Rhino, and we have a very simple layout with some surfaces and some volumes, all contained into a single layer. And let's go ahead and make some room on the side for a new Grasshopper window. And the first thing you notice when you install the plugin is this new tab, this new Esri tab, where we have these three components. And this would be the main Puma component. And I'm going to go into detail about the other two in a minute. Let's just create something on this shape here. For that, first thing we have to do is just to specify which rule we want to use. So for that, we're going to go ahead and create a new file path connected to the RPK, and here we have to select one existing file. Let's go for the Candler Building RPK rule, which is a very basic, simple rule. And next thing we need to do is to specify where we want to apply that rule. That would be a surface in this case. And we can set one surface would be this one. And there you go, we have our Candler building generated right away on this surface. In order to visualize it properly, we need to create a custom preview component in Grasshopper and connect the model geometry and the materials. And there we have materials and geometry properly generated in Rhino. If you want to see it on render viewport is also possible. We just have to activate the preview of the main components so we can see the right colors, and there it is. So the way it works is the same as we would do it in CityEngine. We when we go a little bit closer to the component, we get this little plus symbol, and we can here display this rollout with different parameters that we would have in CityEngine. For example, let's select the building height, and at this point we can just right click on it and extract parameter, and we would get a slider with a range of values for this attribute, exactly as we would find it in CityEngine. So that's it. It's pretty straightforward. The other two components are the report display and the reports unpacker, and I'm gonna explain that in the next example. Okay, so here we have the same layout as before, and now we are going to open another Grasshopper file. So here we have a set of components that are linked to these other usual geometries, and let's have a look to the first building, for example, which corresponds to this set. And we have pretty much the same layout as before, just the main Puma component with the preview, the path to connect it to the right RPK, the surface, and we just have a longer list of attributes just because this rule is a little bit more complicated and we have more attributes to drive its behavior. So the first thing we notice is that the attributes get automatically packed into groups. These green groups are very useful to pack the attributes into different categories, which will help us to find our way when we are working with complicated rules with many attributes. And this building on the side is corresponding to this other setup here. And here we can jump directly into the other two components that were left, the Puma reports display and the reports unpacker. First of them is the Puma reports display. And what this component is doing is basically displaying the information of the reports inside the Rhino viewport on top of the building. We can see it here. And this admits three types of filtering to um, limit the information that we get. In this case, we can activate one of the filters by specifying the values we are interested in a panel element. So we can, for example, connect this list of values to the report key filter, and then the amount of information gets reduced to the ones that we specified on this element. And this is valid for all the three filters. So it's a way to reduce the amount of information. The tag element is just a native Grasshopper component, and it enables the information on the viewport. And the reports unpacker, it's useful to unpack the reports data information from Puma into lists of shapes, shape index, report names, and report values. So we can connect a panel component to drive this information outside of the rule. And this is typically used to further process the reports with other built-in Grasshopper components. So we could connect this information to other components or other rules, and this is the great thing about Grasshopper, that it enables for this kind of flexibility. And for example, we could connect this to a text file and then use it for any other purpose. Basically, this means that we get simple numbers like GFA or FAR or lot coverage out of the volume distributions of our project, and we can dump them into a file. And this data can be used for other metrics or calculations. In the end, it's just the same kind of data that we would get from the inspector panel in CityEngine. This is pretty much the same building we had in Rhino. So this kind of information can be later driven into other Grasshopper components. Along with Grasshopper, with the Grasshopper plugin Puma, we include a very complete user manual, very complete documentation, which is meant to cover all these aspects that I'm explaining right now in detail. And this is pretty much complete at the moment. Last thing I wanted to mention is these other buildings. If we have buildings that are, rules that are going to be applied like these two to a volume instead of shape, we would like to switch off the geometry in Rhino so we can avoid the C clash that is produced by the generated geometry. And this is pretty much the same thing with the Puma report connected to the path. In this case, the volume is not a surface, it's a brep component. And on the other side, the usual reports unpacker. So yeah, this is pretty much it for this example. Let's jump into the next one. All right, so here we have another example of a street segment with a very distinctive street profile, which has been generated using the complete street rule by David Wasserman, and several buildings to the side, which have been generated with different building rules. Now, I wanted to point out that we've been in touch with different urban planners and designers to try to better understand how they use Rhino and which features would make more sense for them to use. And apart from massing itself, which of course is very useful to work out the big numbers of a development project or feasibility studies, another important aspect was related to kind of dressing the bulk volumes to bring them closer to what a real urban landscape would mean. And this way, with relative low effort, give some identity to the project using procedural rules. So Puma has been developed keeping those requirements in mind. Now I'm gonna show you how this scene is built. We have one rule for the street and two for the sidewalks, left and right, and then the buildings on one side and the other side. Something I wanted to highlight at this moment is related to these three buildings, because it turns out that they are driven by only one rule. And this is interesting because it's very representative of how flexible this system could be. In this case, we have a single component connected to the usual path, but the surfaces are not just one, but three in this case. It could be more. So this is exactly what this double cable is showing, that we have more surfaces connected to a single rule. And the same way goes for the attributes. We can see that all three buildings look different, and this is because also the attributes, let's look at the floor count, for example. Here we have a list of values which goes from 4 to 6. So first building would have 4 stories and 5 for the middle one and 6 for the last one. And yeah, that's the way it works. We can apply different attributes for the setbacks and then give different look to different buildings. The exact same thing is happening for this building here or the other one to the side. We have a single component for that rule and several surfaces, several shapes that are corresponding to all the floors. So we can then apply different values, different attributes for each component of the list. So this way we can spare a little bit of Grasshopper components and manage a little bit better the situation on this panel, so it won't get messy right away. All right, so let me turn on the rendered view here so the whole thing looks a little bit nicer. And this is a good moment to bring up the CityEngine window so we can compare side to side. This is the exact same layout that we had before in Rhino, and this is with the model activated geometry. So in the end, what we have is exactly the same rules with the same attributes that we would define here, and we have them in Rhino through Grasshopper. And that is exactly the goal of this whole plugin, to have the possibility of running any CGA rule inside Rhino and Grasshopper environment. The Puma plugin is at the final development stage, so it would be ready in a matter of weeks. And the plugin will be free and open source, so anyone could adapt it to their needs. I think I'm gonna wrap it up here, and just wanted to say that we are very excited about this tool because it will enable Rhino users to take advantage of the powerful CityEngine rules, and I am sure that it will open interesting new possibilities when these two worlds get connected. So that's it. I hope you found this presentation interesting. Thank you very much for your attention, and see you soon.